3.
Hello everyone, welcome to my presentation. Today I am going to present a research to reduce the residual stress produced by thermite welding in periodic rail steel. Here are the three major key components. One is residual stress, second thermite welding, and third is periodic rail steel. Now, let me give the brief introduction about these three components. Now, the periodic rail steel, it is the steel used in the rail weld because of its hardness, toughness, and its mechanical characteristics. Now, welding is simply a technique to join any two metal components. And in the rail weld, thermite welding has numerous advantages over other welding. So thermite welding is one of the best suitable method in rail weld. But it has a drawbacks where it produces residual stress, compressive and tensile residual stress. Tensile residual stress is the main drawbacks, which results in the initiation of cracks of the rail welds and it also decreases the service life of the components. Now, what happens due to the reduction in residual stress? If the tensile residual stress is reduced, we can have mainly three advantages. First, it increases the service life as is shown in the figure. It decreases the possibility of crack in the rail weld, and it increases the fatigue life. Now, let us move to the literature review. Well, what are the studies that are done with respect to welding, thermite welding, periodic rail steel, and residual stress? At first, two metal sections were joined together by bolting, but a massive wear was produced. To overcome that massive wear, welding is introduced. After the advancement of technology, there were different types of welding used to join two metals. Finally, thermite welding was the best and is the best option to join the rail welds. But also, every process has its disadvantages. Like that, thermite welding has disadvantages in these major topics: microporosity, centerline defects, core lapse, and residual stress. Microporosity is the process of forming small pores in the weld, and the core lapse is the insufficient of fusion between two joining components. And the residual stress is the simply the when the metal is subjected to the welding, and due to the temperature difference, cooling and heating, the stress is formed in the weld, which is called residual stress. We can see in this figure residual stress during welding, where this black portion of the residual stress formed during the welding method. Now, let us study about the residual stress, how it is measured, how it is measured, and what are the process to eliminate it, and the study related with this residual stress. At first, residual stress should be measured in order to eliminate residual stress. So, a study shows Newton diffraction, X-ray diffraction to measure the residual stress, and then the FEM analysis was done in the heat affected zone of the welding. Another study also reveals laser cladding as an alternative of thermite welding, but it only has advantage in residual stress. Rather than that, all other advantages are gained by thermite welding. Another study shows when there is improvement of current thermite welding to a new aluminum thermite welding, it possesses some advantages. Now, in the literature review, there are different studies which shows elimination of residual stress. There are 5 research which proposed 5 different types of elimination of residual stress. The first one is post-weld heat treatment, where after the welding, by heat treatment, the residual stress is reduced. Second, milling operation. After welding, milling operation is used to reduce the residual stress. Third, ultrasonic impact. The greater the ultrasonic impact, the lesser the residual stress. Cooling method. Cooling method is also used as an alternative to reduce the residual stress after welding. And the last, vibratory method. It is also one of the method which is discussed in the literature review to reduce the residual stress. Now, what is the research question of this research? It's from the previous slides. We knew residual stress is one of the major problem concerning about the welding. Now, it shows it must be eliminated. So, why should it be eliminated? Because it initiates cracks at the welding. Furthermore, it decreases fatigue life. It also decreases service life of the steel. Now, for that research question, a proposal of research design is proposed. For that, we carried out in 2 different ways. One is experimental design, second is correlation design. Now, 5 samples of P91. P means pearlitic steel. Pearlitic steel of P91 sample is taken, and the calculation of residual stress is done after using Newton diffraction method to calculate the residual stress. Here, out of many different methods to calculate residual stress, Newton diffraction method is followed as it is one of the latest and most reliable diffraction method, which shows the very accurate result of residual stress. Then, the 5 methods that are discussed before, cooling, ultrasonic impact, vibration, post-weld heat treatment, are used to reduce the residual stress. After that, FEM analysis is done to measure the residual stress. And after FEM calculation is done, the results are compared, and the residual stress where it is least, that treatment is selected as the best treatment process for this. And the FEM analysis compare between the methods, graphs, charts, and we come to the conclusion to select a new method to reduce residual stress. Now, what are the advantages and disadvantages of this research design? While we select a new method, all the process is based on experiment, so we can rely on the data produced by the results. Now, FEM analysis is done, which is very practical, so the comparison is very best. What are the disadvantages? The length of these steps are very long. It is very lengthy to select a new method, and the method is very expensive because we have to use FEM analysis and diffraction method. These are the references that are used for this presentation slides. Thank you. That's the end of my presentation.